Let's take a look at the quotient rule. So let's suppose we have a function, f of x, which looks like g of x over h of x. So in other words, our function is one function divided by another. Then the way we take the derivative, f prime of x, is according to the following formula. We start with our denominator and multiply it by the derivative of the numerator, so times g prime of x, and then we subtract off our numerator, g of x, times the derivative of our denominator. And this entire quantity gets divided by h of x squared, so the square of our original denominator. This formula here is what's called the quotient rule. Quotient, the word quotient here, just coming from the fact that f of x was a quotient, or one function divided by another. Now, because of the negative sign that we see in the formula here, the order of the terms in the numerator matters. So what I think about is just starting the formula with the denominator. If you remember to start with h of x, then you'll get your terms in the correct order. So for our example, let's use a different variable here. Let's say we've got a function given in terms of t, and our function looks like t squared minus 6t plus 7, all divided by 3t minus 2. So there's f of t. We're going to find our derivative, f prime of t, and once we've got it, we'll want to figure out where is f prime of t equal to 0, and we also want to figure out where is our derivative undefined. So to answer those questions, let's start with our quotient rule formula. Well, according to our quotient rule, we are going to start with our denominator, so 3t minus 2. And we're going to multiply that by the derivative of our numerator. So our derivative will be 2t minus 6. And then we're going to subtract off our numerator, t squared minus 6t plus 7, multiplied by the derivative of our denominator, so times 3. And this entire quantity here has to get divided by the square of our original denominator, so divided by 3t minus 2, all squared. Now, in order to answer the question of where is this derivative equal to 0, we will need to do a little bit more simplifying here. So let's see if we can simplify the numerator. We'll take a couple of steps to do that. And as for the denominator, this is already factored. So let's just leave it factored. There's no reason to expand this out. So this is a common pattern that we'll run into with the quotient rule. We will normally simplify the numerator. We'll have to expand out and collect like terms, whereas the denominator, we'll just leave that alone and then come back and answer these two questions. So let's continue up here. To get going with our numerator, let's expand out this first product. We've got 6t squared minus 18t minus 4t plus 12. And then when we get over here to our second term, one thing that might help us speed up this calculation a little bit, notice we've really got a product of three things here, because we've got a minus 1 times this bracket times 3. So a little trick I would use here, let's just cross out that 3 and make it a minus 3 in front, we've still now got the same quantity, but we can now expand this out, just multiply through by negative 3, and we'll start to get that expanded. So we've got minus 3t squared plus 18t minus 21. Okay, and we'll just make sure as we expand through that really all our signs do change, because we've got a negative sign in front there. So this entire quantity is divided by 3t minus 2 all squared. So let's see if we can collect some like terms in our numerator. We've got 3t squared. We've got some 18t's and minus 18t that will cancel. And so we've got minus 4t taking care of that, and then we've got minus 9 left over. So there's our simplified numerator, and this is still over 3t minus 2 squared. So let's get going on answering our questions now that this is completely simplified. We would like to figure out where this derivative is equal to 0. Okay, so let's remember that if we're trying to set a fraction equal to 0, if we want a over b to equal 0, imagine multiplying both sides by b here. That's the same thing as saying a has to equal 0. This is something that often students will struggle with remembering what to do here. So just remember, if you're trying to set a fraction equal to 0, all you want to do is just grab that numerator and set that equal to 0. Okay, now looking at this, I'm thinking that it's probably not going to factor nicely. You can play around with it for a little bit if you like to see if it's going to factor, or perhaps faster would just be jump into the quadratic formula. Even if this polynomial here does factor nicely, quadratic formula will still give you the answer. So that would be my, my natural impulse here, is just jump into the quadratic formula. So t is going to equal negative b plus or minus the square root of b squared minus 4ac. And that is all over 2 times a, so all over 6. All right, so we're looking at 4 plus or minus the square root. And we could grab a calculator at this point if we wanted to check what we've got under here. You can check yourself that it works out to 124 under that square root. And that's all divided by 6. Now, in order to get this simplified, we really want to see if square root 124 can be simplified at all. The first thing you might notice as you try dividing 124 through by various square numbers, 2 squared, or 4, is going to divide into 124. So we can actually think of 124 as 124 is 4 times 31. So that means root of 124 is square root of 4 times 31. And if we bring out that 4 out of our square root, that's going to give us a 2 root 31 there. Okay, so that's all just calculation that I would do over on the side there. This guy here is the same thing as 2 root 31. So we can simplify this a little bit by pulling a factor of 2 out of our numerator. We've really got 2 plus or minus root 31 left over after we factor out that factor of 2. And we've got a 6 in the denominator. So we can now cancel a factor of 2 from the top and the bottom, and this gives us our 2 t values that answer the first part of the question. So we use the t values, 2 plus or minus root 31 over 3 those are the two t values that make our derivative equal to 0. So in other words, these are places where, if we think about what t prime or f prime of t equals 0 really means, these are places where the tangent line has a slope of 0. So in other words, the tangent line is horizontal. Okay, well, let's go on and answer the second part of the question. We're going to figure out where f prime of t is undefined. Okay, so if we recopy our f prime of t, remember it looked like 3t squared minus 4t minus 9, and that was all over 3t minus 2 all squared. So if we want to figure out where f prime of t is undefined, what we now need to do is set the denominator equal to 0. This quantity here is going to be undefined when we're dividing by 0. So we need 3t minus 2 all squared to equal 0. Okay, that's the same thing as 3t minus 2 equal 0. You could think of it as taking square roots of both sides, if you wanted to think of it that way. 3t is equal to 2. So that gives us the t value. T is equal to 2/3 is the answer to the second part of the problem.